RSA was the very first public key crypto system that was invented. So let me show you how it works. What we're going to do is Alice is going to send publicly some set of information to Bob, and Bob is going to be able to use that public information to encrypt messages, send the encrypted version publicly, and then Alice and only Alice is going to be able to decrypt those messages. Here's the setup. Alice is going to choose two very large primes, P and Q, multiply them together to form N, choose an encryption exponent E that is relatively prime to P minus 1 times Q minus 1, and she's going to publicly publish N and E. Bob has N and E. He's going to choose a message M to send to Alice. He's going to compute C, the cipher, which is M to the E modulo N, where N and E are those that Alice gave, and he's going to send publicly the cipher to Alice, C. In the meantime, Alice is going to compute the decryption exponent, which is a number D, such that D times E is congruent to 1 modulo P minus 1 times Q minus 1. That, by the way, is phi of P times Q. And then to decrypt the message, she simply computes the cipher to the dth power. So the message itself is the cipher to dth power modulo N. Why does that work? Because the cipher to the dth power is M to the E times D, and that is congruent to M modulo P times Q, because E times D is congruent to 1 modulo phi PQ, and that's because of Euler's theorem. Here's an example. Alice is going to pick very large primes, 53 and 59, N is going to be the product of those primes, and E, 11, is an exponent, the decryption exponent, that is relatively prime to this number. And she's going to publish 31, 27, and 11. In the meantime, she's also going to compute the decryption exponent. 11 times D is congruent to 1 modulo 3016, and that is 1371. Now, Bob wants to send the word no, which if you just translate letter by letter into numbers, that is 1415. So he's going to send the number 1415 to Alice. To encrypt it, he's going to raise 1415 to the encryption exponent and reduce it modulo N. That's 589. And then he can send publicly 589 to Alice. And then to decrypt it, Alice is going to compute 589 to the decryption exponent, and that is 1415, which she can understand is the word no. Now, why does it really work? It works because to compute the decryption exponent D, you have to find a solution to this equation modulo P minus 1 times Q minus 1. And to know this number, you really need to know what is the factorization of N. And that, because N is a product of two very large numbers, is very difficult to do. So the security relies on the difficulty of computing D.